In this example, we're being asked to carry out a time calculation. A patient is to receive 500 ml of 5% glucose. The drip rate is 25 drops per minute. If the drop factor is 20 drops per ml, how long will the infusion take? The first thing you need to understand is that you mustn't get distracted by the presence of the 5%. That's simply information about the makeup of the prescribed solution and forms no part of your calculation. We're going to rearrange our VT-DF1 formula, and I'm going to show you how to set it up to calculate time. So, time in minutes equals volume in mils over drip rate in drops per minute multiplied by our drop factor over 1. Again, structurally very similar to the drip rate calculation and also to the NHS1 formula that we use for basic medication calculations. So the next thing we have to do is to insert the information that we've got in this problem into that formula so that we can set it up and start to think about solving it. So our time will equal our volume, which is 500 ml, over our drip rate of 25 drops per minute, multiplied by 20 drops per mil over 1. As always, we need to cancel down the fraction on the left-hand side. With 525, we can see that there's a common factor of 25. 25 goes into 500 20 times, and into 25 once. I've gone there for the highest common factor. You could have used 5s if you wanted to, but just to save time, I've gone for the one-step method there. We're now left with a formula that looks like this: 20 over 1 times 20 over 1. 20 times 20 is 400. Again, we can think of 2 times 2 being 4, and then carrying across our 2 zeros that we removed to make that easier for us. So 400 and 1 times 1 is 1. So we're left again with a raw solution of 400 over 1, which is equivalent to 400. And don't forget, as we were working out time, that's given us our solution in minutes. You may want to stop at 400 minutes, but the question may have asked you to break that down into hours and minutes, and it's important that you know how to do this as well, because this is a very common area of confusion. Remember that there are 60 minutes in an hour, so to break that down to hours and minutes, we divide 400 by 60. Again, we can use the cancelling process to give us 40 over 6. Both even numbers there, so we've got 20 divided by 3. We now need to think about how to convert our 20 over 3 into a useful representation of time. I'm not going to go with the bus shelter division method in this instance, because never mix decimals with hours and minutes. It just doesn't work. The best way to think about this is turning this improper fraction into a mixed number. So how many whole numbers? Remember, when we're working in thirds, a whole would be 3/3. Do we need to make 20 thirds? We can add them up as we're going along. Repeated addition works quite well here. So 3/3 plus 3/3 would give us 6/3. Another 3 gives us 9. 12, 15 and 18/3. We've got to stop there, because if we added on another 3 we'd be at 21, which is more than the number that we're trying to get to. So we can count our wholes there. 1, 2, 3, 4, 5, 6. So we have 6 wholes, which would be 6 whole hours. And the difference between 18 and 20 is 2. So we have 2/3 of an hour remaining. We now need to find a sensible way of working out how many minutes are represented by 2/3 of an hour. Okay? We know that there are 60 minutes in 1 hour, so we're effectively trying to find 2/3 of 60, and this is actually quite straightforward to do in your head. 1/3 of 60 equals 20. 60 divided by 3 is 20. So therefore, 2/3 of 60 must be 2 lots of 20, which would give us 40 minutes. We can then write out our complete answer in full, which is 6 hours and 40 minutes, which is the time it would take to complete that infusion.